Alright, I'm going to give you a quick rundown of how to use the Papyrus profiling parser. It's pretty simple in practice, but I'll walk you through each step. So first of all, you need to choose a file. You can go ahead and navigate up to the Choose a File box and click it. That's going to bring up a pop-up window where you can find the file you're looking for, select it, and click Open to add it. If you don't know where to find this file, by default, Skyrim is going to put your profiling logs in Documents, My Games, Skyrim, Logs, Script, Profiling. Yeah, it's a mouthful. So you go ahead and navigate to that folder, find the file you're looking for, select it, click Open, and it'll pull it in. Or alternatively, if you have your File Explorer open, you can navigate to the same folder and click and drag onto the box. And that'll work just the same. Now, both methods also support selecting multiple files at once. So you can go ahead and select one and then shift click. And then if I drag and drop all of these 7 files onto the box, it'll support multiple files. And what this does is it takes all of the data from each of them and it bundles them together. This is particularly useful for stack profiling logs because stack profiling logs don't have a lot of data in them, but you end up with a large number of stack profiling logs. So doing this lets you bundle all of that together and gives you a greater capacity to run like statistical tests on the data. So once you've selected your file, you go ahead and click Parse. And that's going to bring up a series of tabs that each have a unique table inside of them. The first one you'll see, regardless of what log file you're working with, is stack timings. That's going to tell you when each unique function instance started and stopped. So with that information, you can figure out how long that function instance took to run, but it doesn't give you any granular detail as to why it took that long to run. This is good for getting a broad strokes understanding of how long certain functions are taking. If you want to get a better sense of why they're taking that long, you navigate to the other tabs. The other tabs are one for each unique function or event that's called within the script you're profiling, and they contain data. Each row is an instance of the function or the event you're taking a look at in the tab, and they've got a stack ID, a queue push, a queue pop, and a pop. The stack ID is referring to the parent function that's calling these functions. So when you look at stack ID 2325 here in getActorValue, we can say that the parent function corresponding with stack 2325 is the one that called that instance of getActorValue. You see right below it, there's another instance that has the same stack ID. And the reason it has the same stack ID is because we know, based on this information, that getActorValue is actually called twice within that same function, within its body. Now, they've also got queuePush, push, queuePop, and pop data. They don't necessarily have all of these properties filled out because queuePush and queuePop may not actually happen. But what each of these different properties holds is a timestamp in milliseconds. So right here, you can see 63047 for queuePush for the first instance of getActorValue. That tells us at that exact millisecond mark, that is when that function instance entered that execution state. It went to queuePush at 63047, and it went to push at 63059. Now this is particularly useful information because given that these are in milliseconds and given that they happen in sequence, we can go ahead and subtract one from the other to get the elapsed time between states. If you subtract queuePush from push, that will tell you the amount of time that the function spent in the queue waiting to start executing. If you subtract push from pop, that'll tell you how long the function took to actually execute. And if you subtract queuePush from pop, that'll tell you, for this function instance overall, the length of time that it took to complete. And with that kind of information, you can start to gauge which functions are taking too long, where the time is adding up. And that gives you a good sense for how to approach refactoring your program, if need be. Now, all of this data is organized into a tabular fashion for easy export into Excel, for easy visualization, and it's an improvement over what's originally in the log files. In the log files, they're not split up by function, they're not split up by event, and the data isn't grouped together with queuePush, push, queuePop, and pop all in one line. Those things might be separate, and they might not even be in sequence. So this tool, just in that area alone, gives you a better ability to visualize the timings for each instance, something you'd have to piece together manually on your own. Now, if you want to take this into Excel, there are two main options. You can export the file as a CSV, that's a comma-separated value sheet, and that can be imported into Excel. It's really simple to do. You just go to the button, you click it, and then that's going to go ahead and download that to your computer. It's local, it doesn't come from any kind of online server or anything, so you don't need to worry about what you're downloading. It's strictly the stuff from the table. If you don't want to download a CSV sheet, you can go ahead and just click the Copy to Clipboard button, and that's going to copy the entire table to your clipboard, so you can just go to your Excel tab and paste it. And it will even keep the formatting that it has in the tab. So, that's the short of how to work with this. Hopefully you find it useful. Let me know if you have any feedback, things that don't work, things that I could improve, and thanks for checking it out.